In this particular circular motion problem, we have a 1,200 kilogram car is rounding a curve of radius 50 meters at a constant speed of 20 meters per second. Assume the road is level and no external forces are limiting the motion. So we know the radius is 50 meters. We know the velocity. The velocity is 20 meters per second. How can that help us find the centripetal force? So the formula for the centripetal force is going to be force centripetal is set equal to the mass times the velocity squared over the radius. Realize that centripetal acceleration would be the velocity squared over radius. So that would just mean that we just went from the centripetal acceleration, right, mass times acceleration, down to bite-sized pieces with velocity squared over radius. So now we just fill in the variables. So 1,200 times 20 squared all over 50, and you end up with 9,600 newtons for your centripetal force. So in terms of your mu for static friction, so the mu for static friction is really dependent on the centripetal force over whatever your mg is. And so since the centripetal force is 9,600, you're dividing that by the mass, which is 1,200, times 9.8, and that gets you roughly 0.82 as the coefficient of friction.